Oh no, not another strawberry video. Well, yes, actually. I don't know about you, but my timeline on LinkedIn was actually filled with this problem, which has been around for a while. Namely, that when you ask certain LLMs like ChatGPT or even Claude, how many R's there are in the word strawberry, that they will consistently get it wrong. They will either say there's two R's, and if you keep prompting them, especially Claude 3.5 Sonnet, is really adamant about, no, 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 you are wrong. And I'm like, excuse me? But what I found really interesting is that in my last cohort, Claudia pointed out, like, hey, Mike, there's one model that seems to get it right from the start without extra prompting. And that is Grok. The model that was trained and designed and developed by the people from X, so also known as Elon's model. And if we ask, of course I should add a prompt, how many R's there are in strawberry? This is funny. Claude kind of differs each time we ask. Sometimes it's 2, sometimes it's 3, but Grok takes a slightly different account. It doesn't just return an answer. It will say, hey, to count the number, let's break it down into individual characters. And it will actually mark the R's and then count them and say, hey, we've got 3 R's here. Now, this is interesting because this looks like Grok actually does like chain of thought prompting out of the box without us asking for it, which is really interesting already. But also it's able to recognize that strawberry is one word. And why is this special? Because of a thing called tokenization. Well, imagine, whenever you input a line of text or a question or whatever into a large language model, contrary to what its name suggests, doesn't understand language. It's a software model, it's a computer model, and as such, we need to convert what we see as language into something binary. These binary things that a large language model works with are called vectors, vector embeddings, and to get from language to vector, we need to encode these words into something numerical. And the first step on our way of doing so is to tokenize the input that we give to a large language model. And to tokenize basically means to chop up your input into smaller chunks and assign a numerical value to these chunks, so that later on we can send these numbers to the next step, the vectorization step. And it's interesting because each model tokenizes the input in a different way. And to make it a bit less theoretical, we can actually have a look at how models do that, because Hugging Face, which is a great place to start with any kind of research that you want to try out, has got this thing called the tokenizer playground. So this will basically show you how a model like Claude, in this case, but we've got other ones as well, how it will tokenize words and sentences that we give it. So when I ask Claude to tokenize the word strawberry, you can see that it chops it up in 3 discrete chunks, 3 discrete tokens, and each token has its own numerical value. And this is what actually gets processed by the next step in the pipeline, the vector embedding step. So it's interesting, right? Because this is not how we would chunk a word like strawberry. Like if you learned how to chop up a word, you probably did it by speaking the word or clapping, like strawberry, 3 syllables, or straw and berry are like 2 morphemes, like 2 separate words that if glued together form a new word. But that's definitely not how large language models work. This is a way of tokenizing that we call sub-word tokenization. So there's no human meaning in these tokens. This is literally like a tokenization strategy that works really well for large language models because it kind of distributes the token to vocabulary kind of ratio, how successful that is. Way too much information for this small video. But the thing is that I wanted to show you how Grok tokenizes this word. And as you can see, Grok actually tokenizes strawberry as one word, which means that even though we turn it into numbers later on, all the meaning information about this word still is kind of contained within one token. At least that's what I assume, because hey, I'm not a machine learning expert. And that gets even more visible if we actually input the entire question that we had for Grok. How many R's are there in the word strawberry? And you can see that it tokenized each word as a token. So each word is a token, which probably means that some of that information that we put in there might still be retrievable once we start statistically inferring and probabilistic, like next token prediction. Again, if we go back to Claude, that's interesting. You can also see that tokenization of the same word is not always the same over all sentences. So that means that if you want to compare tokens or compare vectors, which is a large part of how an LLM works, we don't have an equal start situation to begin with, because strawberry as just one word is tokenized differently than strawberry in a sentence. I'd be really interested to see what happens. Okay. Oh, I lost strawberry. So that's not a lot of use, is there? We can have one final look at how GPT-4, strawberry please. So GPT-3 tokenizes this as one word, but so as you can see, this tokenization is well, I wouldn't call it messy, because I'm sure it makes sense from a probabilistic and economic point of view, but from a human linguistic point of view, it's definitely not how we tend to process language. One final thing in me. No, I'll keep that for a separate video, because this morning I got a really interesting article on my timeline about a model that has been trained with reflection tuning that kind of does chain of thought reasoning like baked in. But I think this might not be as groundbreaking as the title suggests, because apparently Grok is already doing that, at least for this example. So yeah, I hope you find this useful. Tokenization, have a go if you like at huggingface.co.spaces, Xenova, the tokenizer playground, and see what's happening under the hood of your LLM. Groetjes, tot soon!